Okay, so in section 10.4, we are going to look at hyperbolas. And hyperbolas have this shape that we see right here. And let me zoom out a little bit so that we can see them better. Okay, so they have this shape that we see right here. That red graph right there is your hyperbola. There are many parts of a hyperbola that we are supposed to know. These 2 points right here that touch the x-axis in this picture, those are called your vertices. They are sort of the turning points of the graph there. Hyperbolas also have what we call slant asymptotes. So you can see right here, these dotted black lines, they're not actually part of the graph, but they are what we call the asymptotes of the graph. So as the graph approaches, gets closer and closer and closer to the left, it gets closer to that line. A hyperbola also has what we call a conjugate axis and a transverse axis. The transverse axis is going to go through the two vertices. The conjugate axis doesn't actually touch the graph at all, but it goes halfway between the vertices. It doesn't touch the vertices, but it's halfway between there. Also, I did not mark it, but the center of this hyperbola, it would be right here in the middle, halfway between those vertices. So we're going to learn several things about finding different things about a hyperbola. So the standard form of a hyperbola that opens to the left and the right, and that standard form of a hyperbola that opens left and right is going to look like this. I don't know what that is. Okay, let's try that again. Okay. X minus h squared it's a square right there over a squared minus y minus k good gracious, this is so heavy, squared over b squared equals 1. And so whenever you see this equation, it looks almost identical to an ellipse. The only difference is that you're going to have that minus sign in between. And now this hyperbola opens to the left and to the right because the x value is positive, and we've got a minus in front of the y. We're going to also look at hyperbolas that open up and down, and that will be the opposite for them. So just like with an ellipse, the center of this graph is going to be at h K. The vertices of this graph, if we look, if it opens to the left and the right, the vertices of the graph would be right here, to the left and to the right. So this point right here is our center. And so we would need to go to the left and to the right, however far the vertices are away. Well, we can find that by taking the square root of a in this case. So our vertices are going to be at h plus or minus a. And then we don't go up or down any, so the k here is just going to stay the same. Okay, and then the equation of the transverse axis is going to be the one that passes through the center. So that transverse axis is this axis right here on the graph, and it passes through the center, and it's a horizontal line for these types of graphs. So a horizontal line is a y equals equation, and so y is going to equal k in this case, because the y coordinate of your center is k. There are a lot of other things that I could teach you about hyperbolas. We could find the equations of those slant asymptotes. We could do the conjugate axis. We could do a lot of different things for hyperbolas. However, I do not want to go that into depth with those. So we are just going to stick with center vertices and transverse axis. The next thing we're going to look at is a standard form of a hyperbola that opens up and down. And so if the hyperbola opens up and down, the equation looks almost the same, except for the y is going to be positive. So you're going to have y minus k squared over b squared minus x minus h squared over a squared, and that's going to equal 1. So in this case, notice that minus comes before the x minus h here. So the center of this is still h. Okay, be a little careful with this, because a lot of times when you see these, they'll be written in this order, and you want to say kh, because k comes first, but the x coordinate is going to be whatever's in the parentheses with the x, and the y coordinate is whatever's in parentheses with the y. So in this case, your vertices on the graph, they would be right here, up and down from that center point that you have. So the vertices for this graph are going to be h, and then we'll have k plus or minus, and underneath that k you've got a b squared, so it's plus or minus b. And then in this case, your transverse axis would be this vertical line right here, and it goes through the center. So since it is a vertical line, vertical lines are x equals equations, and our x coordinate of our center is h. So it's going to be x equals h is going to be the equation of that transverse axis. Okay, so let's look at what we're going to have to do for some of these. We're going to write in standard form and sketch a graph. We're going to do a very basic sketch of a graph. Now, what you're going to find here is that these are going to be very similar to the ellipse as far as solving the equation. So we're going to group our x's and our y's. So we're going to have 9. I'll make this a little bit bigger so maybe I can write a little bit better. 9x squared minus 54x. So make it 5 a little better. Okay. And then we're going to have minus 4y squared minus 40y, and I'm going to go ahead and move that 55 over to the other side. Okay, so now, just like with the ellipse, I'm going to factor out whatever coefficient I have in front of my x squared or my y squared. So here I'm going to have 9, and I'm going to have x squared minus 54 divided by 9 is going to give me 6x, and I'm going to put plus blank. Okay, here's where we're going to find the slight difference between an ellipse and a hyperbola. So right here, that 4 is negative, so we want to factor out a negative 4. And so when we factor out a negative 4, we're going to have y squared here, and then we're going to do negative 40 divided by negative 4, which is going to give us a positive 10y, and then we're going to put plus blank, and that's going to equal 55. I'm running out of room there. I'm right on my graph. Whenever we do this, now we need to complete the square, so this 9 just hangs out front. And I'm going to take this 6 and divide it by 2, so I'll have x minus 3 squared is what's going to go in the parentheses. 3 squared is 9, so that's the number that I'm going to add in the blank up here. Now remember, you have to multiply this 9 by the 9 that was pulled out front. So rather than adding 9 to the other side, we're going to have to add 81. Okay, because we have to do 9 times 9 there. All right, and then we're going to have minus 4, completing the square again, so we're going to have y plus 5. 10 divided by 2 is 5. Then when we square that, 5 squared is 25. Now, right here, we're going to have 25 times that negative 4 right there. So 25 times negative 4 is negative 100. Okay, so notice that's a minus there that we're adding to that side. And so if we do 55 plus 81 plus 100, let's see, that's going to be 55 and 81 is going to give us 136, and then we're going to subtract 100, so we'll get 36 right here. And so just like with an ellipse, we want these to equal 1, so we need to divide everything by 36. And so when we do that, 9 over 36, that reduces, we get x minus 3 squared over 4. And then we're going to get y plus 5 squared over 9, and that equals 1. So that gives us our standard form of the hyperbola. Now, our center, we need to know that to be able to graph this. The only two things I'm really going to require, or I'm going to say three things I'm going to require of you on the graphs of these, is you need to be able to find the center. You need to be able to find the you'll be able to find the center, the vertices, and then know which direction that this one opens. And let me erase this up here so I got room to graph. All right, so our center in this case is at 3, -5. And I always think it is helpful in this case to know which direction this graph is going to open. Since your x is positive here, this is going to open left and right. So if this point right here is 3, -5, we're going to have to go to the left and to the right to find the vertices, and we're going to go to the left and to the right the square root of 4, which is 2. So we're going to go to the left 2 units and to the right 2 units. So if we go back up here to the graph, the actual graph, if we put the center here at 3, -5, that's right here, sorry for the bad graphing, then you go to the left 2 and to the right 2 for that. Now, a lot of things about this graph could be much more specific. I just want you to draw me in the correct shape opening in the correct direction. You do not have to be able to do this perfectly. And so we'd have a hyperbola that looks a little bit like this whenever we graph it. Most of the things that you're going to have to do will be able to figure them out pretty easily through some Desmos graphs. So I'm not going to emphasize the graphing too much on this. All right, let's look at another question. So in this question, I have to write in standard form and sketch a graph. Now notice here, I've got a y squared and an x squared and a 20x, but I don't have any typical y terms. So my y squared is just going to stay out here, and I'm not going to complete the square for it. For my x squared, I've got to factor out a -5. And so when I do that, I'm going to have x squared plus 4x plus blank, and that's going to equal 50 plus blank. Okay, so the y I don't have to do anything with, but the x I'm going to have to complete the square for that. So 4 divided by 2 is 2, so I'm going to get x minus 2 squared, and then 2 squared is 4, so I'm going to add that up here. Now remember, we have to do 4 times -5, so we're going to actually be putting a -20 over here, and so that means that this is going to equal 30. Okay, just like with an ellipse, we need this to equal 1, so we're going to divide by 30. for all of these terms. And so we will have y squared over 30 minus 5 over 30 is going to reduce to 1 over 6. So I will have x minus 2 squared over 6 equals 1. And so for this, I need to know my center. And the center is going to be at 2, 0. Be a little careful with that there because some people may want to put 0, 2 because the y comes first and it has a 0 with it, although we don't see it. But whatever is with the x is your x coordinate. So you've got a 2 there, and then the 0 goes as the y coordinate. So 2, 0 is going to be your center of this graph. Since our y is positive, this one is going to open up and down. So the graph will look something like this. And so if this center right here is at 2, 0, then we need to look, we need to go up and down, so we need to look underneath the y. We're going to have to go up and down the square root of 30. So if we went up, our vertices would be at 2, and then you're going to have 0 plus the square root of 30, so I'll just give you square root of 30 there. And then we'd have 2, and we'd have 0 minus the square root of 30, so you'd have negative square root of 30. Now, if we're going to actually graph this, we're going to need an approximation for that square root of 30. So if you type that into the calculator, the square root of 30 is 5.47, so about 5.5. So if we are estimating here, we need to go up about 5.5. So 1, 2, 3, 4, 5.5, about right here. And we need to go down 5.5, which will get us about right here. And then we're just going to draw in our hyperbola. We don't have to have a real perfect graph for this. We just need something close. Okay, and the homework assignment that's going to go with this is going to come from page 650. I'll upload that to Canvas so you can see a picture of that. I'll also put the answer key there. However, I do only want you to find the center, the vertices, and to sketch a graph of those. So any other information that it might give you on that answer key, you don't have to find. Just center, vertices, and a very rough sketch of the graph is all I need for those. Please email me those or send me or you can send me a picture of your work in Remind, and I'll get those checked off for you. Thank you.